Welcome to my channel Phi Concepts CHM. This is the third part of the series of gradient, divergence and curl. In the earlier video we saw about divergence. Now we will see another operation, that is curl. Curl of a vector f bar, that is del cross f bar, can be found in this determinant form. In the first row comes the unit vectors I cap, j cap, k cap. In the second row we have the components of the del operators, that is dabba by dabba x, dabba by dabba y, dabba by dabba z. And on the third row we will take the components of the vector f bar, that is p, q, r. Now we will solve this determinant. So that will be I cap into dabba r upon dabba y minus dabba q upon dabba z plus j cap into dabba p by dabba z minus dabba r upon dabba x plus k cap into dabba q upon dabba x and dabba p upon dabba y. So this way we find the curl of a vector. We will take an example. We will take f bar is equal to xz I cap plus xyz j cap minus y square k cap, and we will find its curl. In the same way, we will write down the determinant form as I cap, j cap, k cap and dabba by dabba x, dabba by dabba y, dabba by dabba z, and in the third row we will write down the components of the vector f bar, that is xz, xyz and minus y square. And we will solve this determinant, that is I cap into dabba upon dabba y of minus y square minus dabba by dabba z of xyz minus j cap into dabba by dabba x of minus y square minus dabba by dabba z of xz plus k cap into dabba by dabba x of xyz minus dabba by dabba y of xz. So we differentiate this with respect to x. There is no term of x. Sorry, we should differentiate this with respect to y. So we get this y square, differentiation of y square is 2y, so minus 2y minus differentiate with respect to z, this will be xy. So minus 2y minus xy into I cap minus, here there is no term of x, so the differentiation is 0, minus here differentiate with respect to z, you will get x, and here with respect to x we differentiate, we get yz, and here there is no term of y, so the differentiation is 0. So final equation we get is minus y into 2 plus x into I cap plus xj cap plus yz k cap. Curl f versus divergence f. Divergence f is a scalar field. It gives the operation gives a scalar field, and the curl f, this operation gives a vector field. The curl of a gradient vector field is 0. So that is given here, curl of del f, this is the gradient of f, that is 0. That can be proved here. Same way we can take del cross del f. So on the first row we have write I cap, j cap, k cap. On the second row we have these components of this del, and in the third row we have the gradient of f as dabba f by dabba x, dabba f upon dabba y, dabba f upon dabba z. So we solve the determinant, we get I cap into dabba square f, this multiplying this 2, we get dabba square f upon dabba y dabba z minus deba square f upon deba z deba y plus deba square f, this 2, multiply these two, deba square f upon deba z deba x minus deba square f upon deba x deba z into j cap plus deba square f deba upon deba x deba y minus deba square f upon deba y deba x into k cap. So these two are same, these terms are the same in the brackets, you can see. So that comes as 0. So curl of a gradient is 0. Also for conservative field, if the field is conservative, the curl is 0. Here an example is shown where the field is given, and if it is a conservative field, so its curl comes as 0. So the reason for the name curl is that the curl vector is association with rotations. The curl of a vector field measures the tendency for the vector field to swirl around, to turn around. Now here particles near this point xyz in the fluid tend to rotate about this axis that points in the direction of this curl f bar. The length of this curl vector is a measure of how quickly the particles move around the axis. A rotational vector. So this diagram, if you think of a fluid flowing in one direction, so here it is there is no rotation. So we say that the curl will be 0. So if curl f bar is equal to 0 at the point P, the fluid is free from rotations at the point P. So f bar is called irrotational at point P. If the curl of a vector field is 0, then the force field is known to be conservative. So that means there is no whirlpool or eddy at the point P. So the fluid is not rotating the way it does in a whirlpool. Now we will see about a paddle. If the field is even here, then it would push on all sides equally and the paddle wouldn't turn at all. If the curl F is 0, a tiny paddle wheel moves with the fluid, but it will not rotate about this axis. It will move, but it will not rotate about this axis. The axis should also rotate. So if the curl of the vector field is 0, then the force field is known to be conservative. It means the water is pushing harder on one side than the other and making this axis to twist. So larger the difference, the more forceful the twist and the bigger the curl. If the curl F is not equal to 0, that means the paddle wheel is rotating about its axis. Let's see a problem that if A bar is equal to minus yi cap plus xj cap, find the curl or del cross A bar. So again we will write it down in the determinant form. The first, here you have the unit vectors, components of unit vectors, here the components of the del operator, and here the components of this vector, that is minus y, x and 0. So solving this determinant in this way, I cap into this is 0 minus deba x upon deba z minus j cap into this is 0 minus deba y upon deba z plus k cap into deba x upon deba x plus deba y upon deba y. So what you get here is, again this is with respect to z, there is no term of z, so the differentiation is 0. Here also there is no term of z, so the differentiation is 0. and last terms you get as 1 and 1. So the answer is 2 into k cap. Thank you for watching this video.